Hello everyone. Now the full subtractor. Earlier we have discussed the half subtractor. In case of half subtractor, there are two binary inputs are there. So there is a difference, and whether there is need of borrow, then it should be calculated. But now in this case, if the two input and one borrow in there out, because whenever we are subtracting, if borrow is generated, then it is also taken as the input. In that case, the full subtractor is to be used. Let's take the block diagram of the full subtractor. Now this is the block diagram of the full subtractor. In this case, there are two inputs A and B, one borrow in, and the difference is calculated, and whether there is a borrow output is generated, that is to be displayed with the help of borrow output. Now firstly consider, or let's consider, the truth table. Now this is the truth table. In this truth table, what happens, there are two input A and B, and one is borrow in. Sometime when borrow in is, in some cases it is 0 and some cases it is 1. So there are two combination of input, that is 0 0, 1 0 and 0 1 and 1 1. For both of the four combination, there are two borrow in, 0 and 1. So that makes the total 8 inputs that we have already used in full adder subtractor, full adder case. So now when in first case, when both the difference becomes 0 and the borrow in is 0, again it is subtracted, then total difference is 0 and there is no need of borrow. Now in case of 1, when the borrow in 1 and both the inputs are 0, the difference of these two is 0, then from this 0, when 1 is subtracted, then there is a need of 1 borrow, then the difference is calculated as 1. Now again the combination has been changed, it is 0 and 1. When it is 0 and 1, that is subtracted, so there is a need of borrow and the difference is 1. And when from this difference the 0 is subtracted, then again the difference is 0. Now in case of 0 1, when the borrow in 1, as we know, there is a need of borrow, the difference is 1. From this one, when this borrow in is 1 is subtracted, the difference become 0. Now the next combination is 1 0 with 0 and 1 0 with 1. So when 1 0 with 0, then the difference is 1, there is no need of borrow. But when 1 0 is with 1, the difference is 1 and 1 minus 1 becomes 0 and there is no need of borrow. Now when the combination is both the inputs are 1 1, then the difference is 0 and there is no need of borrow. But when the combination is 1 1 with carry in as 1, the difference is 0. From this 0, when we have to subtract this 1 carry in, then we need a borrow and the difference is 1. So that is what the truth table for this full adder subtractor. Now from this truth table, we are going to generate the K map. Now there are two K maps, one is for difference and another is for borrow. Let's take the difference of this. So there are different combinations of x, y, or we can say A, B, C. So A complement A, AB complement, or XY, YZ complement, Y complement Z, YZ, and Y's complement Z. So from this truth table, whatever the position where the difference is 1 1, we mark this on K map. From this K map, we are going to calculate the values. So that values are x, y's complement, z complement, x complement, y complement, z, x, y and z, and x complement, y and z complement. So from this we are going to calculate this. If simplification is possible, then further we are simplifying, otherwise this we can use for calculating the chart. Now similarly for borrow, in case of borrow, there are again 4 positions where there is 1. So we are going to mark them in K map. 4 ones is there out, and from these ones we are going to calculate the functional value, Boolean functional value of this. So from these two Boolean functional value, we are going to generate this K map where A and B are XOR. The difference of this and borrow in gives a the difference, and then A naught B AND gate XOR borrow in and XOR of A NAND gate gives an AND gate, and that is what borrow output. So that's what's the full digital diagram of the full subtractor. Thank you.